Hey there, spaced out viewers. Welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. Let's take a look at Helios. In the ultraviolet emissions from ionized helium, it's the Solar Dynamics Observatory imagery. 304 angstroms, great at showing filaments. A new sunspot has risen in the southeast. We'll get into the in-depth coverage of that shortly. Here's the colorized magnetogram. This is an alpha-class sunspot. The likelihood of it producing major flares is very low. At the moment, it's only got one umbra. Although large, it's only one polarity. Here's the northern hemisphere. The portion of El Sol, which has been producing the majority of the activity in terms of sunspots in the past week or two. Currently, the southern hemisphere a little more active. Large coronal hole just rotating past the Earth-facing zone and sunspot rising to your screen left. Here's a close-up of that rising sunspot in this same wavelength. And let's blast through a whole host of other data, like the radio flux. The most proportional data set that we have on sunspot number is the 10.7 centimeter radio flux. It's directly proportional to sunspot number, and it's something discovered in 1947 to give us ideas about solar activity besides counting sunspots. Each solar flux unit represents 10,000 joules. And that's radio flux density, by the way. There's the one-year chart to put it in context. The black line there is the radio flux. The red line is the sunspot number, which has briefly dropped back down to 0, and it's coming back up today. So all the way down to 77 for the radio flux. And there is some geomagnetic unrest forecast late tonight and early tomorrow on October 19th. Full moon coming on October 20th. More coverage on that momentarily. We saw some brief periods of geomagnetic unrest. The heck? For some reason, showing us old data here on the Space Weather Enthusiast dashboard. Let's move on to look at global seismicity. Largest quake of the past 24 was a 6.1 near Vanuatu. There's the location of that 6.1 magnitude earthquake. Nearly 100 kilometers depth for that one as well. Let's hope that's not a foreshock. And let's scroll up the list here from USGS. Some earthquakes happening in Hawaii there. Some 5+ magnitude quakes here happening south of Kamchatka, and it looks like on Kamchatka. The Bonin Islands south of Japan saw a 5.1. Deep quake near the Fiji Islands at nearly 500 kilometers depth and a 4.8 magnitude. That 6.1 magnitude quake came in early this morning at 7:26 Universal Time. And Kamchatka did see a 5.2 on the peninsula. That quake deep at over 172 kilometers estimated depth. How about volcanoes? We see some new ones back on the list here. First, La Palma. La Palma, a little uptick at La Palma here, 13,000 foot ash plume produced from the Canary Islands volcano. Cumbre La Viejas. Suno Sejima, flight level 070, it's producing a 7,000 foot ash plume. Manam on Papua New Guinea now exploding. 8,000 foot ash plume from that. Samisa Pochnoi, 6,000 foot ash plume from the Aleutian Islands volcano. Samisa Pochnoi exploding with occasional eruptions. Fuego in Guatemala also exploding. Volcanic ash plume up to 15,000 feet of altitude there. Also Nevado del Ruiz exploding. 21,000 foot ash plume is fertilizing Colombia. Sangay exploding, 20,000 foot ash plume over Sangay. That's an uptick at Sangay. Revenador exploding, 15,000 foot ash plume from the other Ecuadorian active volcano. It's exploding, Revenador and Sangay in Ecuador. Also, Sabancaya exploding, 25,000 foot ash plume over Peru. Nevados de Chilean exploding, 13,000 foot ash plume produced by sporadic emissions. Our reminder to not pole vault the caldera, but do visit our links. By the way, if you'd like to pick up some merch from the Red Bubble Shop through October 21st, you can save 20 to 60% store-wide using the promo code SHOPEARLY. Just enter the promo code SHOPEARLY on checkout and save 20 to 60%. You can find links to all of our designs here at smAsho.com, as well as below this video in the description. So check them out. Maybe advertise the face of evil, Dr. Fauci. And define the word fraud for your friends and foes, which means an intentional misrepresentation of material facts, something St. Fauci, the face of evil, has been doing for well over a year. So welcome to the Neo Renaissance. Congratulations on realizing our channel exists. Head to our homepage, click on Smash Team, SMAsho merch. If you've got contributions for our forum, check that out. You can read our mission there as well, smashomash.com/forum/mission. Let's look at magnetic data. The GOES 16 and 17 are measuring magnetism, and we saw some very low readings around midnight time for the GOES 16 last night, making it all the way down to 33 nanotesla there. And there's a coronal hole wind stream on the way, which is likely affecting the measurement of magnetism. So here is the top view ecliptic plane field plot, part of the Gong 2 National Sunspot Observatory data. And I wouldn't be surprised to see a North Pole current sheet showing up promptly, and you can actually see it happening here. Right at the end, you can see a North Pole current sheet sort of accelerating Earth's way. And that has to do with that sunspot forming in the southern hemisphere. Here's a line of sight ecliptic plane field plot, which also shows you the solar magnetogram. You can see that rising sunspot there in the southeast. And you can see that blue line moving about. We can expect to be solidly in a North Pole current sheet. I'd say by tomorrow's video. Tomorrow's daily space weather. Line of sight coronal hole plot showing a well-defined coronal hole in the southern hemisphere shown in red. Again, there should be a significant coronal hole wind stream from that, a high-speed stream of plasma, primarily hydrogen nuclei, otherwise known as solar protons. Highly charged particles are on the way. So here's a visualization of that. This is 193 angstroms from the Solar Dynamics Observatory. You can see the definition of that coronal hole, especially in the southern hemisphere. Great view of that from the Solar Dynamics Observatory. Continuing on, I did find some alien spacecraft here on stereo A imagery. I just wanted to see how intense that sunspot looked. And there you go. Caught some alien spacecraft there. Please tell Gina Maria Colvin Hill, Mr. MBB333, and any other hack frauds on YouTube that are going to spread fear and nonsense about what that is. Looks like it could be some coronal ejecta. But in any case, let's move on. No major solar flares in the past 3 days, just B-class intensifications. 2 of them have occurred today. Minor B-class flares, probably from sunspot 2884, which is, I think, the name of the new rising sunspot. No spikes in the proton flux, no coronal mass ejections headed our way. How about the real-time solar wind? We've seen a small uptick here over the past few hours. Although the BZ has moved into positive territory, so the total field here remaining quite strong. Still at 10 nanotesla. The BZ at positive 8. So there's that North Pole magnetism already showing up. Current solar wind density around 13 protons per cubic centimeter. Solar wind speed 346 kilometers per second. Let's take a look at the geospace after we look at global geomagnetism. There's the KP index over the past 3 days, and you can see these brief periods of geomagnetic unrest those were caused by pure magnetism, folks. This ongoing strong negative BZ component coupled with a strong BT are what caused that geomagnetic unrest. It wasn't from an increase in the solar wind density or velocity. It was just pure magnetism. Let's take a look at magnetism here over the past 4 hours. And we see a homogeneous plasma sphere here around Earth, at least as modeled by the Space Weather Modeling Framework. Again, it's 4 hours of data courtesy University of Michigan. And you may see a little increase in the pressure here in the last bit of the movie. And you do indeed see some bow shock pressure there showing up on your left side of your screen. There's that little increase. That is the increase in the solar wind speed and density, although minor. Let's look at ground magnetic perturbations next. Geospace delta B changes to Earth's B field. The B field, by the way, for you new viewers, is the field that goes through the magnet. When we showed you the coronal hole line of sight plot, the blue lines were the sun's B field. These are ground magnetic perturbations here on planet Earth. You can see some over places like Iceland and Greenland, also northern Canada, and around the south magnetic pole, which is someplace in the Southern Ocean down here, south of Australia, during this polar excursion. Next, a diagram of the solar system. Mars still looking lonely here. Mercury is making its way around to give Mars some company on the other side of the sun. Full moon coming up in 2 days. Let's advance this 7 days. There's where things will be on the 25th of October. Happy Smashtober, by the way, folks. Thanks to all of the Smash Team members. SMASHOMASH.com/Smash Team. And here's a star chart. Yeah, you can use cookies in-the-sky.org. The yellow line here is the ecliptic. That's the path the sun will take across the sky. The blue line is the galactic plane. Let's continue on. My star chart faces the south. And let's do a brief cosmology segment. We're not going to pick a random number today. We're going to talk about the Geminga pulsar. One of the more interesting portions of the Milky Way galaxy is the Geminga pulsar. It's a consistent X-ray source, as you can see here. The past 16 years have been pretty standard X-ray output. Here's a 30-day chart. And let's take a look at this visually speaking. We'll zoom in using the Chandra X-ray imagery. And there is the Geminga pulsar. You can see a jet-like feature there stretching down to toward the lower right of your screen there. Interesting little tidbit about the Geminga pulsar. Viewing it in optical light does not yield very much of a signal at all. It's a dark spot that is bright in X-ray. So if you go to the CDS portal, you come down here and you look at the photometric points, you can see that it lines up. It's very bright in only these wavelengths, but not the other wavelengths, as you can see. Let's take a look at it in infrared. And once again, you can see how dark it is at Geminga. So yeah, dark in infrared, dark in optical. It's dark in UV also, folks, trust me. And there it is in X-ray. The Geminga pulsar, today's featured cosmologic object. Next, the astronomy picture of the day, talking about Earthshine, or perhaps you'd like to call it Da Vinci glow. Leonardo da Vinci talked about Earthshine. If you see a partially full moon, like a crescent moon, the part of the moon that is also illuminated but darker, that is largely illuminated by Earthshine. Anyway, that's the astronomy picture of the day. apod.nasa.gov if you want to check it out yourself. A great image there over Sicily. Let's take a look at cosmic rays. We'll look at about 7 different cosmic ray monitors here. Here's the Apatity neutron monitor. The middle frame there is the last 30 days. And you can see a minor downtick over the past 30 days in cosmic ray flux from Apatity. At Barentsburg, a slightly more marked downtick in cosmic ray flux over the past 30. Let's go a little farther south here to Athens, Greece, to look at the Athens neutron monitor. And there's Athens. You can see it's quite flat here over the past 30 days at Athens. Let's go even farther south to Mexico City. Mexico City, slightly downward trend there. You could maybe say that's flat. That's a 30-day chart. By the way, historic data is available on the Mexico City Cosmic Ray Observatory. And we'll also look at Oulu, Finland. There's Oulu, Finland, a downtick at Oulu over the past 30. And 2 Antarctican monitors showing a similar downward trend. There's DOMB Antarctica. And, oops, there is DOMC Antarctica. Quite a similar chart there. The data looks legit. That's today's cosmology segment. By the way, we've got a massive playlist with over 230 videos. I think exactly 230 videos in our cosmology segments. YouTube.com/smAsho/playlists is where to find those. And if you're new to the channel, please press like and subscribe. Share the content with your friends, foes, science noobs, and science pros. We have a theory that the algorithm is being less than helpful. Let's look at charging hazards. We ain't got none. No charging hazards at the moment for satellites, typically caused by, especially surface charging caused by electron flux. Here's the 1-year chart of the relativistic electrons from Solon.info. How about a 3-day chart? There's the 3-day chart as measured by the GO16 and GO17. And there's the total electron, there's the relativistic electron forecast. And I would tend to agree with this coming downtrend as there is some coronal hole high-speed wind stream coming. Next, a diagram of Earth Van Allen belts. Distances are shown here in miles because we're going to show you the total electron content forecast next. So the total electron content forecast is showing you electron density between your GPS satellite and your GPS handset and the likelihood of errors. The redder the blobs get. Everything looking pretty organized here, nothing to write home about in the total electron content forecast. We're also going to show you the ionograms and the anomalygram of the F ionosphere layer located about at 300 kilometers of altitude. Here's the ionogram. We are seeing some pretty marked anomalies here, both in the low and high frequency variety. Frequencies making it up to 14 megahertz here over places like the Central Atlantic, South America, and the West Pacific. You know, the areas around the equator where you would expect it to happen. Anyway, there's the latest image. That's 9:45 universal time. Here's the anomalygram showing you the departure from the 30-day median in megahertz. And you can see, again, some major low-frequency and high-frequency anomalies here. The low-frequency ones happening primarily in the central Indian Ocean. Major low-frequency anomalies there. Also over places like Indonesia, Papua New Guinea, etc. High-frequency anomalies starting in places like the Atlantic Ocean. The South Atlantic anomaly, which, by the way, is about here on the South American continent. And there is a smaller weak spot in the ionosphere right about there. Or should I say weak spot in the magnetosphere. It's the South African anomaly, as the South Atlantic anomaly seems to have split into two before finding itself over the South American continent. Anyway, here's the latest image. That's 9:45 universal time. You can see lots of low-frequency anomalies there, especially in the eastern portion of the planet. All right, here come bonus features. Let's take a look at the El Teide, Spain ground-based solar observatory to get the latest hydrogen alpha imagery from El Sol. I believe it's called Sunspot 2884, or it will be called that soon. Here's the latest intensity gram. Again, it's only alpha class. It only has one polarity umbra. If that changes, the likelihood of solar flares goes up. And here's the full disk view. Some activity happening there as well. If that looks like it is a sunspot, that looks like a small beta class sunspot there, folks. So there's a little tidbit. We'll see if that one stays on the Earth-facing portion of the disk long enough, I think 12 hours, in order to get a name. Here's my favorite wavelength from the SDO, 171 angstroms. It sort of shows you the magnetic looping of the lower corona. And we'll close out today's video with a close-up of the new sunspot. Sunspot 2884, I believe it's called. Thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back.